Hello, guys. Hope you have been having a lovely day, and welcome to another episode of Aptitude series. In this video, we are going to solve problems on heights and distances. Before we begin solving problems, we need to understand a few basic concepts of trigonometry. All of trigonometry begins with a right-angled triangle. So to begin with, we need to look at our trigonometric ratios. Draw a right-angled triangle, mark theta, which is our angle, and you can mark opposite, adjacent, and hypotenuse. Hypotenuse is always, as you know, the side opposite the right angle. So sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tan theta is basically sine theta by cos theta, which makes it opposite by adjacent. Cosecant, secant, and cot thetas are basically the reciprocals of sine, cos, and tan thetas respectively. The next important thing that we have on our plate are the trigonometric identities. Well, these are not very common and probably you won't use them in every problem that you solve, but it is handy to know them. Sine square plus cos square theta is 1, secant square minus tan square theta is 1, cosecant square minus cot square theta is 1. And the next thing that you have to remember are the values of sine theta and cos theta for a given angle. Well, you don't have to remember it for every angle, but you do have to remember it for 0, 30, 45, and 60 and 90 degrees. Well, if you look at this, sine theta is 0, 1 by 2, 1 by 2, root 3 by 2, and 1 for 0, 30, 45, 60, and 90 degrees. And cos theta is the exact opposite of what sine theta is. And once you have the value of sine theta and cos theta, you can always find out the value of tan theta because it is basically sine theta by cos theta. And tan theta is not defined at 90 degrees because, as you know, the division with 0 is not defined. And the next thing that we need to remember are the angles of elevation and depression. So angle of elevation is basically the angle subtended by the line of sight and the horizontal. So if basically an observer is looking at an object that is above him, there is an angle that is subtended by the object with reference to the person and the horizontal. That is the angle of elevation, and the reverse is the angle of depression when the person or the observer is looking at an object that is below his eye level. The first question we are going to solve says, the height of a tree is 5 root 3 meters, the length of the shadow caused by the sun is 5 meters, and we are being asked to find out the angle of elevation of the sun. We can draw a triangle to represent the same, where theta is the angle of elevation of the sun, 5 root 3 is the length of the tree, and 5 is the distance or the length of the shadow. So now tan theta is the most convenient ratio that we can use, which is opposite by adjacent. That gives us tan theta is equal to root 3, where theta is equal to 60 degrees. Therefore, the angle of elevation of the sun would be 60 degrees. For our next question, it says, there is a ladder leaning against the wall at an angle of 60 degrees with the floor. Find the height of the wall if the length of the ladder is 22 meters. Well, in this case, since the sides we know are the hypotenuse and the opposite, since the sides involved are the opposite and the hypotenuse, the best ratio to choose is sine theta, which is opposite by hypotenuse. So sine 60 is the wall height by 22, which gives the wall height is equal to 11 root 3 meters. Now, in addition to what he has asked, we can also find out the distance between the foot of the ladder and the wall, and for this, since the sides involved would be the hypotenuse and the adjacent, you would take cos theta. So cos theta is adjacent by hypotenuse, which would give the distance between the foot of the ladder and the wall as 11 meters. And for the next question we have, there is a man on top of a building. He sees a car approaching towards the building. The car takes 30 minutes for the angle of depression to change from 30 degrees to 60 degrees. What is the time taken by the car to reach the building from the existing location. Now we can represent the same using a right angle triangle where M is the man, B is the base of the building, H is the height of the building, and C1 and C2 are the positions of the car. So we need to understand that since alternate angles are equal for parallel lines, the angle of depressions for the man's point of view are the same as the angle of elevation from the car. Now here, since the sides involved are the opposite and the adjacent sides, tan theta is the best ratio to choose from. Now here we are going to solve this by finding out what x1 and x2 are relative to each other. In that way, when we understand that it takes 30 minutes to cover x1, we would know how much time it would take to cover x2. So now tan 30 and tan 60 we find out from the triangles that we have, which give us x1 plus x2 is root 3h and x2 is h by root 3. Now here we can equate, or we can say that x1 is nothing but x1 plus x2 minus x2. And on simplifying that, we understand that x1 is equal to 2x2, which means to cover x1, if it takes 30 minutes, to cover x2, it would take only 15 minutes by inverse proportion. Therefore, from the existing location, the car would just take 15 minutes to reach the building. Now, for our next question there are two trees on either side of a river. From the top of one tree, the angles of depression of the top and the foot of the tree are 30 and 60 degrees respectively. What is the height of the other tree if the height of the tree the depressions are being measured from is 36 meters? Now I'm going to represent the same in this figure. Just MG is a mango tree and GV is a guava tree, and I'm assuming that the height of the tree which we are supposed to find out is H. It is obviously smaller because we are measuring the angles of depression from the taller tree. Now, since alternate angles are equal, I can write that the angles of elevation from the top of this tree and the bottom of this tree to the top of the taller tree are 30 and 60 degrees. Then, since mg is actually 36 meters, I can write mc as 36 minus h and cg as h because it is exactly opposite gv, which is h. In addition, I am denoting the distance between the two trees, which is basically the width of the river, by d. Now, in cases like this, before we actually find out the height of the other tree, we need to find out the distance between both the trees, which is nothing but the width of the river. The perfect way to do this is using tan 60 is equal to 36 by d, which gives us d is equal to 12 root 3 meters. Now we picture the second triangle GMC because we have the value of GC. Now we find out the value of 36 minus h, which will ultimately give us the value of h is equal to 24 meters. Hence, the height of the second tree is 24 meters. Problems based on heights and distances are generally very easy to solve and really score fetching. And I would like to close this session by giving you an example where they ask you to solve a problem without providing adequate data. Say there is a man who watches the top of a tower and the angle of elevation is 30 degrees. He walks some distance and then the angle of elevation is 45 degrees. Now they are asking us to find the height of the tower. So in cases like these, by looking at the options, we might get into thinking that one of them has to be correct. But you have to be sure that in cases like this, you can go ahead and tick the data not sufficient option. I hope you have found this video helpful and informative, and thank you very much for watching it. And if you have an exam that is coming up, I wish you all the very best. Stay blessed and keep rocking. Thank you.